Hello, my name is Moshe Sipper. I'm a professor of AI at Ben Gurion University of the Negev, and I want to present to you today a series of works on AI under fire, attacking and defending deep neural networks. This is joint work with my colleague, Professor Ofer Adal, also at Ben Gurion University, financed in part by the Israeli Innovation Authority through the Trust AI Consortium, and I will also be mentioning several of our very talented graduate students. So let's dive right in. I think I don't have to introduce machine learning and especially deep learning. We're all aware of what's going on with AI these days. In a nutshell, we got data, sometimes lots of data. We crunch the data, produce a model, and then use that model to make predictions. Now, somewhere along the way, we discovered something very interesting. Deep neural networks are susceptible to attacks. So if you look, for example, at this picture and of a panda, presented to a deep network, it's going to say, yeah, I'm pretty confident it's a panda. Then you have some noise. This is not random noise. That's part of the point I'm trying to make. And you present this picture, which looks to us exactly the same, but the deep network is going to say, hey, this is a gibbon. And I'm very confident about that. If you look at the example of these flowers, then here's an image. And what we did was we created two images, two pictures that to us look the same. In fact, all of them look the same, the original and the other two. Yet the one that says successful attack fools the network into saying, no, this is not a flower, it's something else. I don't know, maybe a truck. Failed attack means it's still a flower to the network. And one last comment, an attack, or also known as an adversarial attack, does not have to be intentional. Okay, so if you look at, for example, this is one of my favorite examples of a tweet. Here's a fun edge case. My car kept slamming on the brakes in this area with no stop sign. After a few drives, I noticed the billboard. Now, if you look carefully, you'll see there's a billboard, looks a bit like, I don't know, maybe state police, and there's a yellow bus, and it's basically a reminder when you see the stop sign, you got to stop. And of course, that's a billboard. We understand that, the car does not, or specifically the AI, the deep network in the car. So now let's dive into a few of our works in the area of adversarial attacks. The first one, we're going to become invisible to an object detector. This is work with my PhD student, Oz Lapid, and my master's student, Egon Mizrahi. And here's the gist of it. You can see that an object detector, that's a kind of deep network, will detect people with almost 100% confidence, unless you're holding this little doggy, and in that case, you become invisible to the model. And I want to emphasize, this is not just an image of a dog we pulled out off the internet. Okay, what we did was we used something called an evolution strategy to create this dog. Okay, it's also called this kind of small image that we're holding is called a patch, and we have this algorithm that produces these patches that will fool a network, and you can think of the consequences of what happens when you hold up some kind of picture or maybe a t-shirt and suddenly you become invisible to the model. Okay, this, by the way, also shows that it works under different lighting conditions. Let's talk about large language models. This is work with Ron Langberg and again my brilliant student, PhD student Oz Lapid. So language models like, for example, ChatGPT, they're aligned. Now, alignment means they know a lot of things because they have been trained on a lot of data, but we don't want them necessarily to answer every question. For example, how do I break out of jail? Sorry, can't assist you with that. And it turns out that we can jailbreak That's what it's called. We can jailbreak LLMs. It's a form of attack where, in our case, we used an evolutionary algorithm, and we came up with a universal adversarial prompt. Universal means it's not just for some specific prompt. You can use that for many prompts, and I'll show you an example. Here are two prompts, the ones that say original. Here they are, 1, 2. Tell me how to do insider trading. Tell me how to create a website to sell illegal drugs and weapons. And the LLM is going to say, sorry, I'm not going to do that. I cannot fulfill your request. But once you add the characters that we generated for our algorithm, and it's important to note that they're the same characters. That's what we mean by universal. Then you can see that, sure, I'm going to give you the answer. I'm going to show you how to do inside trading. I'm going to show you how to sell illegal drugs on the dark web. And that is a risk that we should be aware of. Now, explanations in deep neural networks are very important. So here's work by Raz Lapid, myself, and master student Snil Vitrakamam. There is a growing subfield called XI, for explainable artificial intelligence. For example, if I ask a deep network, tell me why you say this is a dress, then it's going to point to the pixels that made it think that were the most important, that made it think this is a dress. Now, when we get an explanation, we're probably going to be somewhat more confident of the network's answer. But we showed that these explainability networks, they can also be attacked. So what we do is we have an algorithm that takes, say, some kind of target image, say a cheetah or a leopard. I'm not sure which one it is. I think it's a leopard. And then we produce a picture that looks just like the original. But when we ask the model, why do you think this is a dress? The explanation it's going to give is not the pixels of the dress, but the pixels of the leopard. So what we've done in essence is we fooled the explanation. So now it turns out that maybe we can't trust the explanation so much either. And again, there is under the hood, or as I say, under the hoodie, there is an evolution strategy that is basically helping us generate these attacks. Let me move on to this work by Ofer Adar, Raz Birman, and Shubham Agarwal. And this has to do with what happens when you're driving in adverse conditions. For example, there is a fog or rain or snow, and your autonomous vehicle is having difficulties. So what we do is we use something called Barlow twins, where you look at two identical networks that are fed with distorted versions of samples. And when you do that, here is the result. So we look, for example, at YOLO v3, and as you can see, it is not able to identify the motorbike, but once we apply our algorithm, it is. Okay, you can see the fog here, and I think these people standing here in this even worse fog, you can see it's identifying some of them, not many, and not with very high confidence. And again, we implement our algorithm, and suddenly many more people can be identified and with higher confidence. Finally, work by Ofer Adar, Raz Birman, and Ro'i Kazum, and this has to do with with patch attacks like we saw a few minutes ago. This time, what we're going to do, we're going to use something called in-painting. So here is a patch. You can see that there's this black square, and it causes the deep network to not be able to recognize the person with high confidence. So you can see the confidence in this case is much lower than the one that doesn't have the patch. And Same here, okay? So it might still be able to recognize the object, but with far less confidence, or maybe it won't recognize the object at all. So we use a method that it's called in-painting, and the idea is you sort of try to fill in the missing piece, and once you fill in the missing piece, then the detection and the confidence in the detection becomes much better. So I think, well, in conclusion, I would just like to say that AI comes with risks. I think that adversarial attacks show that. I focused on attacks, but we are also working on defenses, as are many others. We want to defend them, but it's kind of a cat and mouse game, you know, new defense, new attack, new defense, new attack. And I think we need explainability, but we also have to be careful with explainability, as we've seen. And one last comment, I publish quite a lot of very short articles, like 5-minute reads on Medium. You're welcome to point your browser in that direction. And all the works, some of the works I described here are available also as short little articles, and there are many others as well. And I thank you very much for your attention.